Hi math lovers, and welcome to another video of our channel from the series 100 problems around the world. Today we have selected a problem from Bolivia Math Olympiad of 2022. It is an IMO, International Mathematical Olympiad team selection test. So the tests that are being done in every country to select the team that will represent every country to the yearly International Mathematical Olympiad. The problem states, find all possible values of 1 divided by x plus 1 divided by y if x and y are real numbers not equal to 0, such that x cubed plus y cubed plus 3x squared y squared is equal to x cubed times y cubed. So, as always, if you have any solution to share for this problem, please write it down in the comments. If not, let's see one together. So we have covered the solution as always, and let's see how this problem can be solved. Now, we rewrite the request of the problem, so we are asked to find all the values of 1 divided by x plus 1 divided by y if x and y are real numbers not equal to 0 such that they fulfill this condition. So, as it often happens in this kind of problems, we should try to, let's say, to manipulate the given condition. So, in this problem, let's do it by rewrite the sum of x and y as s and the product of x and y as p. So the condition x cubed plus y cubed plus 3x squared y squared is equal to x cubed times y cubed becomes x cubed plus y cubed is equal to s cubed minus 3ps. So if you do the calculation over here, this is the formula of the sum of cubes, which is expressed in this way when you substitute x plus y as s and x y as p. On the other side, x squared y squared is equal to p squared and x cubed y cubed is equal to p cubed. Now the given condition under these new substitutions will become from the given form it will become as s cubed minus 3ps plus 3p squared minus p cubed is equal to 0, or if we factorize in this case the expression, we will get that s cubed minus p cubed minus 3p, which multiplies s minus p, is equal to 0. So we factorize s minus p, and we will have this form. So the given equation becomes under this form. So what we could do in order to solve this problem is that we will try to furtherly, manipulate this expression in order to have something with which we could work with. So we have that s minus p is equal to x plus y minus x squared, and let's see how we can further elaborate s squared plus sp plus p squared minus 3p. So by doing the substitutions of what s and p represent, we will get, after doing some elementary multiplyings and factorizations, we will get that the given expression is equal to x squared plus y squared minus xy plus x squared y plus xy squared plus x squared y squared, which multiplied by 2 is equal to x minus y all squared plus xy all squared plus y plus xy all squared divided by 2 in order to have parity. So the given expression of the problem is now equal to this expression. So from this form, under this new intermediary form, we reach this final form of the given condition. And upon this form of the equation, we can now do our reasonings. So it was a little bit of heavy calculation, but not too much if we are talking about IMO team selection tests. So problems are usually hard. So it's not quite easy to become part of the national team of the team selection in the team selection test. So now in the equation number 1, it is much easier to do our reasonings, because in order for this expression to be equal to 0, we have only two cases. Either x plus y minus xy is equal to 0, or the other factor, the other term, is equal to 0. In the first case, when x plus y minus xy is equal to 0, we get that x plus y is equal to xy, and we can divide both sides by xy because x and y are not equal to 0. In this case, we will get that 1 divided by x plus 1 divided by y is equal to 1. So one possible value of 1 divided by x plus 1 divided by y is equal to 1. In the case 2, when this factor is equal to 0, we have that on the left hand side we have three perfect squares. In order for this left hand side to be equal to 0, all three perfect squares should be equal to 0, from which we get that x is equal to y, and each of them is equal to minus xy. In this case, we easily derive that x and y are equal to minus 1, so another possible value of the equation 1 divided by x plus 1 divided by y is equal to minus 2. So finally, we say that all possible values of 1 divided by x plus 1 divided by y with the given condition of the problem is 1 and minus 2. Please let me know if you could think of some easier solution to this problem. If so, write it down in the comments. Thank you for your time and hope to see you on our next uploads. Goodbye.